originally developed with different direct current, right? The availability of the transformer and the development and improvement of induction motors at the beginning of the 20th century led to the use of AC transmission. DC transmission now become practical when long distance were to be covered or where cables are required, as we have discussed this in our old slides. Thyristors were applied to DC transmission. Sometimes we are using the transistors. Okay, sometimes we are using the transistors. So thyristors were applied to DC transmission, and solid state valves become a reality. With the first development, actually I'm suffering from mouth ulcer, okay, so I'm not talking very properly, so please cooperate with me. With the first development of converters like rectifiers and inverters, this thing we have also, I have shown you using the slides. The rectifiers are utilized in the primary side, okay, to convert from AC to DC, because in the transmission line you are using basically the three-phase transformer, right? So three-phase transformer, after that particular value, AC current will be converted to DC, high voltage DC, and then it travels for a long distance, and then it travels, it converts in the AC again by using the inverter. So with the first development of converters like rectifiers and inverters, this is the huge, you have to learn from your syllabus, like 12 phase converter, 6 phase 6 valve converter. Okay, at higher voltages and larger currents, DC transmission has become a major factor in the planning of power transmission. In the beginning of all HVDC scheme used mercury and arc valves, invariably single phase in construction, in contrast to the low voltage polyphase unit used for industrial applications. About 1960, control electrodes were added to silicon diodes, given silicon control rectifiers like SCRs or thyristors. Today, the highest functional DC voltage for DC transmission is of 600 kilovolt. Okay, DC transmission is now an integral part of the delivery of electricity in many countries throughout the world. Comparison of AC and DC transmission, we already did these things. Like the merits of two modes of transmission like AC and DC should be compared based on the following factors, like economic transmission, then technical performance, and reliability. Okay, now economics of power transmission. So in economics of power transmission, in you can say in DC transmission, inductance and capacitance of the line has no effect on the power transfer capability of the line and the line drop. This thing we have also discussed, but that particular thing we have written this thing in the notes. Also, there is no leakage or charging current of the line under the steady conditions. A DC line requires only 2 connectors, whereas AC line requires 3 connectors in 3-phase AC systems. As I discussed in the earlier slides, that in DC system you have two connectors only, and in AC system you have at least 3-phase 3-way system or 3-phase 4-way system like this. The cost of the terminal equipment is more in DC line than in AC line. Break-even distance in one at which the cost of the two systems is the same. It is understood from the below figure. See, this figure we have already drawn. We have shown that this is for AC, that is regarding the economic cost. It is higher in terms of distance, and for DC it is quite lower. Although the two graphs are linear. Regarding technical performance, due to fast controllability. Now, this particular controllability term was there in control system 2, but that control system 2 is not in your syllabus. But controllability we did in the syllabus, which is other in the control system. Yeah, okay, state space. So controllability, you have to control all those parameters from the sending end. So due to the fast controllability, a DC transmission has full control over transmitted power and ability to enhance transient and dynamic stability in associated AC network and can limit fault currents in the DC lines. Furthermore, DC transmission overcome some of the following problems associated with the AC transmissions, like stability limits. The power transfer in an AC line is dependent on the angle difference between the voltage phasor at the two line ends. Okay, because whenever you are going to calculate the AC one, you have to also find the angular difference between the voltage and the current. Then you have to calculate. Okay. Now, for a given power transfer level, this angle increases with distance. The maximum power transfer is limited by the consideration of steady state and transient stability. The power carrying capability of an AC line is inversely proportional to the transmission distance, whereas the power carrying ability of DC line is unaffected by the distance of transmission. Okay, say this is the case of DC and this is the case of AC. Okay, power transfer capability. Then we have voltage control. The voltage control in an AC line is complicated by the charging and voltage drops. The voltage profile in an AC line is relatively flat only for a fixed level of power transfer corresponding to its surge impedance loading, that is called SIL. The voltage profile varies with the line loading. For constant voltage at the line ends, the midpoint voltage is reduced for line loading higher than SIL, that is surge impedance loading, and increased for loading less than SIL. The maintenance of constant voltage at the two end, that means the terminal of two of the DC line requires reactive power control as the line loading is increased. Okay, so the reactive power requirement increase with the line length. That means if you increase the line, then automatically the reactive power is required also be high. Okay, although DC converter stations require reactive power related to the power transmitted, the DC line itself does not require any reactive power, because you know that the DC line is not require any reactive power, but due to minimize the drop, okay, due to provide the same power factor throughout the line, the reactive power bank is required. Okay, the steady state charging current in AC cables poses serious problem and make the break-even distance for cable transmission around 50 kilometers. So in AC lines there is a problem. Okay, AC line there is a problem. Now for line compensation, okay, line compensation is necessary for long distance AC transmission to overcome the problem of line charging and stability limitation. The increase in power transfer and voltage control is possible through the use of shunt inductor, series capacitor, static bar compensators, and lately the new generation static compensator, that is the name is statocom. Okay. In the case of DC line, such compensation is not needed. The problems of AC interconnection. Now, what is the problem? What is the problem in the AC interconnection? The interconnection of two power systems through AC ties requires the automatic generation controller of both systems to be coordinated using the tie line power and frequency signals. Even with coordinated control, the interconnected systems, the operation of AC ties can be problematic due to the presence of large power oscillation, which can lead to frequent tripping and increase in fault level and transmission of disturbance from one system to another. So see, in case of AC lines, what happened? In case of AC lines, say if I consider about a 50 kilometer distance, about 50 kilometer distance, if you increase the line, okay, in that case, obviously there will be a fault will be there, okay. And another thing, suppose if there is a fault in a single say transformer, then entire line has been not in working condition. Okay, so there is a system change. So this thing we have also did in the transformer. When one particular winding is damaged, then the power transform in a reduced state by using two converters. Okay, that is the problem in AC. Okay. Now, the ground impedance, this thing we also did in terms of the ground lines regarding the sea levels. Okay. Now, what is the disadvantage of DC transmission? Okay, the scope of application of DC transmission is limited by high cost of on the last day we have discussed about three disadvantages, but I have find out all those disadvantages from different books. Okay, the PDF different internet files. So we have all concluded this. So high cost conversion equipment, inability to use transformer at altered voltage levels, generation of harmonics, requirement of reactive power, and complexity of control. Okay. Over the years, there have been significant advantages in DC technology, advance in DC technology, which have tried to overcome the disadvantages listed above, except for the second one. These are increase in rating of the thyristor cell that makes up a valve, because you have to utilize the thyristor for the valves. Modular construction of thyristor valve, 12-phase operation of converter. This is very important. 12-phase operation of converters. This is in your syllabus. Okay, 12-phase operation of converter. The use of force commutation and application of digital electronic and fiber optic in the control of converters. Now, this formula you have to know. Okay. Now, what is reliability? Now, the reliability of a DC transmission system is good and comparable to that of AC systems. The reliability of DC link has been very good. So there are two measures of overall system reliability: energy availability and transient reliability. So two kinds of reliability are there. One is reliability, energy availability, and transient reliability. Now, energy availability, this is the formula. The formula is energy availability is equals to 100 into 1 minus equivalent outage time into percent, and this is given in percentage. Okay, so 1 minus equivalent outage time by actual time. So energy availability equals to 100 into 1 minus equivalent outage time by actual time. Okay, so where The equivalent outage time is the product of actual outage time and the fraction of the system capacity lost due to outage. So what is the system capacity lost during the outage? That particular value you have to find out. Okay. Then transient reliability. Okay, transient reliability. This is a factor specifying performance. This is a factor specifying performance of HVDC system during recordable faults on associated AC systems. This is a factor specifying the performance of HVDC system during recordable fault on the associated AC systems. Okay, and the transient reliability is given by 100 into number of times HVDC system performed as designed by number of recordable AC faults. Okay, so these are the different calculations are there in HVDC transmission system. Okay, so transient reliability is given by 100 into number of times HVDC system performed as designed by number of recordable AC faults. Now these things you have to remember in your mind. The recordable AC system faults are those faults. The recordable AC system faults. This is the recordable AC system faults are those faults which cause one or more AC bus phase voltage to drop below 90% of the voltage prior to the fault. Okay. Now, both energy availability and transient reliability of existing DC systems with thyristor valves is 90% or more. So these are the categories you have to know. Okay, these categories you have to know. Now, these applications we have already discussed. I will not tell this thing again because DC transmission underwater cables. So what are the uses are there? I have written here. Okay, like you see 100 megawatt direct link connection in Australia. Okay, so these are the some examples I have mentioned. Gotland 1954 and Sardinia 1967 schemes. So this is the where HVDC underwater cable are situated. Okay. Now, this thing I have not discussed. There is stabilization of power flow. Stabilization of power flow in integrated power system. Now, see, in a large interconnected system, because sometimes we have multi-bus system. So in that case, this stabilization of power is very, very important. Okay, there is stabilization of power flow in integrated power systems. So in a large interconnected system, power flow in AC ties, particularly under disturbance conditions, can be uncontrolled and lead to overload and stability problem, thus endangering system security. Strategically placed DC lines can overcome this problem due to the fast controllability of DC power and provide much needed damping and timely overload capacity. Damping means this damping means it comes under damped. Okay, that means it comes stable. Okay, the planning of DC transmission in such application requires detailed study to evaluate the benefits. Example is the Chandrapur Padghi link in India. Okay, this thing I have already shown in the slide. Okay, presently the number of DC line in a power grid is very small compared to the number of AC lines. This indicates that the DC transmission is justified only for specific applications. Although the advance in technology and introduction of multi-terminal DC systems are expected to increase the scope of application of DC transmission, it is not anticipated that the AC grid will be replaced by a DC power grid in the future. There are two major reasons for this. One is the control and protection of empty multi-terminal DC system. This is multi-terminal DC system is complex, and the inability of voltage transformation in a DC network imposes economic penalties. Secondly, the advances in power electronics technology have resulted in the improvement of the performance of the AC transmission using FACTS device, for instance, through introduction of static VR volt ampere reactive systems, static phase shifters, etc. So this FACTS controller is also taken by Madam. Okay, and these valves, from types of valves, I will start from tomorrow because this is very, very important. So what are the configurations are there? That will start from tomorrow. Okay. Have you understood, students, what we have discussed today? And I will send you these notes by today evening. Okay, in your ERP portal. Students, are you there? So now we'll take your attendance. Sujit Roy, Sanjay Sharma, Nehal Chetri,
Present, sir.
Animesh Burman, Abhijit Rasali, Acha, Vivek present. Joseph Tamang. This is present. Nitya Ranjan. Present. Kritika Rai. Will Moon sir will take your class today? Okay, students.